Hello everybody and welcome back for this second part. Okay. And before I start, I would like to wish you all a very happy new year. Now, as we discussed that this course, the second part will be looking at exclusively on the hazard one, and then second is how important is the geological structures in from the civil engineering point of view. So, let us straight away move into the content of this course, where we will be talking about the natural hazards and its related impact on the environment. Now, here the environment will also include the we will talk about the human impact. What is the impact of natural hazards on the human settlements also. And then we will talk about the geological structures, mainly the active faults and related hazard in India, and we will also include the folds and faults and all that, taking into consideration that how they are important in civil engineering applications while putting the major structures on the surface. Okay. And what is the importance of the faults there, or the folds. Okay. And we will have at least one lecture where we will be talking about the consideration of geological structure while putting the dams and tunnels, or selecting any site for construction. Then we will have few lectures on tsunamis and related hazard, causes, processes, case study. So, in case study we will be talking about what happened in 2004 in India, because we had a very major event of 2004 along Sumatra Andaman subduction zone. Then about the landslides, causes, classification, zonation, protection and land subsidence. Then we will talk about floods. Again, in that we will talk about the streams and river hydrology, type of floods, nature and extent of floods, flood hazard zoning, flood controls and protection, and finally the groundwater. Now, this we have added within request we got in the previous course, that there should be some mention about the groundwater. So, I will try my best to talk on the groundwater part also. Now, as we have listed down here right from the natural hazards, and then we are having active faults here. So, why we will be talking about why the active faults are important, and if you look at here that this we are talking about active, and the faults we have studied in the last course also. Okay. So, we will see that how they are important, and then all this topics which are listed here is a part of the geological hazards. Okay. And it is extremely important for us to know and understand where exactly this events are occurring. Unless and until we are not having the complete understanding of the geological processes, it is difficult to minimize the hazard and risk factor. Okay. So, this is what we will be talking in this course. So, and finally, we will talk some case studies on the hazard part. Textbooks we have listed few, but I would suggest that it is always good that if you follow the slides. Okay. Nevertheless, you can refer the textbooks also for these topics. Now, coming with the first part. Okay. This is the first topic we will be talking about the hazards. Okay. But I would say that these are all natural processes, and in previous course we have talked about that these natural processes are endogenic and exogenic. Okay. Those processes related to earth which are taking place subsurface, and those are we term those as endogenic processes, and exogenic processes which are taking place on the surface. But all these processes, when the human settlements or we face problems, okay, then they are hazardous. Okay. So, we can say they are all geological processes, and if these processes are hazardous to us, okay, then we term this as an geological hazards. Okay. So, why we say that, okay, all geological processes are hazardous, it may not be totally correct also, okay, because if the population is less in many particular area and those processes are not going to affect us, then in that sense they are not hazardous to us. But in view of the tremendous increase in the population day by day, more people are posed to such type of hazards. So, that is one of the reason that why uh, in last couple of decades geological processes are becoming so hazardous to us. So, it is extremely important for us to understand where exactly these processes are occurring and how many people are are exposed to this hazard. So, natural hazards are naturally occurring processes which are dangerous to human life and property. So, mostly we are bothered because they are affecting our lives and property. Earth processes or earth surface is susceptible to variety of natural or geological hazards. Now, these events can happen anywhere. Okay. Now, in terms of the atmospheric hazard, broadly one can classify that the climate change, fog, tropical cyclones, hurricanes, storms, snow or ice avalanches, tornado, thunderstorms, wildfire, etc. And geological hazards, we talk about the earthquakes, slope failures, floods, droughts, volcanoes and tsunamis. So, there are number of things which are hazardous, and we have been talking about, for example, the climate change, of course, because of the increase in temperature and all that, we are facing a lot of problems, and we have experienced in a recent past several extreme events. Okay. So, this was the recent one we had, the Varda cyclone. Okay. Now, again as I was talking about that, we need to know that which type of event will occur where. That is extremely important for us to understand the process as well as to understand that how we can minimize the risk part from out of it. Okay. So, cyclones mostly will be forming in ocean and it will be affecting mostly the coastal areas. Okay. So, this is one recent example which I wanted to share with you, and we all have very fresh memories about it. This was one of the devastating event with a very high velocity which affected the east coast of Indian mainland. So, if you look at some of the details of Varda, how it developed and how it progressed. So, it started developing on 6th of December over Bay of Bengal close to Andaman Islands, and then it moved south westward. It crossed Tamil Nadu coast near Chennai on 12th of December, and after the landfall it moved southwest and weakened. Hardly 18 people were been killed here. Now, this we will talk in very in a short time, that why this was like 18 people were been killed, not more, though it was a severe cyclone storm, but it did not affect many people. Okay. Of course, the effect was very dramatic. It uprooted several large trees, experienced high waves, like the height of the waves were quite high along the coast. Now, the only reason why we see only like 18 people were been killed, the main reason was that this storm was monitored very precisely. So, if you understand, you monitor any hazardous event, you can minimize the life loss and property. Of course, it was difficult to save the property, but yes, we were able to save many people out of from the Indian eastern coast of India mainland. Okay. So, it started developing on Andaman area, and then slowly it moved towards the west. Okay. So, these are the all pictures which were been taken at different time. Okay. This was been taken on 8th of December, where it shows that the cyclone started forming. Okay. So, it has an this is the direction of the clouds movement here, it is moving like this. Okay. Then it moved further west. So, this photograph was taken after on 9th or so, and this is the track which has been shown. So, they knew the velocity, they knew the time, at what time it will reach or hit the coast, hence they issued the warning. So, this is very much important in any type of hazard, that you need to issue the warning. Okay. But in case of only few hazards, you will be able to issue the warning. Okay. Otherwise, it is difficult. For example, this cyclonic part, okay, if you take, they had an opportunity to view this based on the from the satellite data, and they issued the warning. But there are few events which are not occurring so frequently, hence it will be difficult to predict or issue the warning. Okay. We'll talk about the earthquakes and other, because it is difficult to predict until now. Okay. So, this was the track which shows and how it moved. Okay. It originated from here, then it moved across this. So, on this was the final landfall on 13th. Okay. Now, this is what the warnings the way the warnings are issued, but this is a press release which was been given by Ministry of Earth Science and Indian Meteorological Department, Earth System Sciences Organization and all that. Okay. And they clearly mentioned about the wind speed here. Okay. So, if you look at the wind speed here, on they say on 13th, okay, from 12th onwards, the wind speed was quite high. Okay. It is around 100 kilometer per hour, and on 13th it will be around 130 kilometer per hour. Okay. And they have already issued, based on this, they have already categorized this cyclone as a severe cyclonic storm. Along with this, they also issued the warnings for the areas along the coastal zones, like for Andaman, they suggested a very heavy rainfall in that region on 11th, and also they suggested that what will be the wind speed during that period. So, the most affected people along the coast will be, one is the fishermen and the people who are staying along the coastal zones. Okay. So, fishermen were also been issued the warning that they should not venture in sea along and off Andaman Islands and its adjoining areas. Okay. Because it is going to be in severe effects of this storm. Okay. So, and this is the final press release which was been given by again the Meteorological Center, which is very much similar, which they are talking about, that wind speed may go as high as 150 kilometers per hour, that is on 11th and 12th. Okay. And on 13th it will reduce further. Okay. So, again they have also issued that it is this cyclone is severe to very severe in a sense. So, we had an opportunity to look at the satellite data, and this satellite image was been taken on 11th, which shows that at what time it has reached and where. So, you have the time also. Okay. This is 15:30, okay, 3:30 p.m. when it approached this area. Okay. And then finally, what we see is the track. It originated from the Andaman, it moved towards west, and finally the landfall. So, it hit the Indian coast on 12th. Okay. So, we had what we say the proper warning issued for this. Okay. Now, this is another example of the catastrophic events, or we can say geological hazard. There is an earthquake which happened in New Zealand recently. Okay. and which is termed as was been called Kaikoura earthquake in New Zealand. The magnitude was 7.8, and it occurred at very shallow depth, 22 kilometers, and it ruptured the surface, almost covering a distance of 70 kilometers. 36 kilometers was on the land and 34 kilometers under the sea. So, because of this 34 kilometer which ruptured under the sea, tsunami warning was been issued. Okay. And if you carefully look at this boundary here, this is the subduction zone boundary. So, let us see some details of this earthquake. So, I am not going to talk about the rupture here, but what you mean by rupture and all that, but when we are talking about active faults and all that, you may come across this terminologies and all that. But in simple way, this is the surface manifestation of the displacement which occurred during an earthquake. We have couple of videos which shows that how the rupture occurred close to the coastline and on the land. Okay. So, we will be showing those videos. Two videos are there which explains that how the displacement took place during the Kaikoura earthquake of magnitude 7.8. So, we have this is the plate boundary here, and background if you take, this is the boundary between the Pacific plate and we are having the Australian plate. Okay. So, just I am going back to the slide here. So, if you take this one, this boundary, this side is your Pacific plate and this is your Australian plate. Okay. So, there is a subduction between these two plates are taking place, and the movement or the velocity of, we can say, the convergence rate is too high. If you will see this number, it shows around 37 here, 39 here. Okay. So, this and then 34 here. So, these numbers are in millimeter per year. Okay. So, Pacific plate is subducting below the Australian plate, or they are subducting as well as sliding past each other. Okay, because there is a movement which has been given here. So, it is in sort of an oblique subduction which is going on here. But these numbers which are being shown here 34, 37, 39 are quite high. Okay. Because if you take in terms of Himalayas, we have hardly 22 millimeter per year, 21 to 22 millimeter per year across the Himalayas. Okay. So, this also indicates that this area region will experience lot many earthquakes, but it is again is difficult to predict, and at this stage I would say, but maybe in future with the advancement of science one will be able to predict the earthquakes and issue warning in proper time, okay, to save many people. Nevertheless, in this region not many people were been killed, or but the damage was severe, as we can see from a couple of ground photographs, and then land displacement was very prominent in that area. Okay. The destruction was quite severe, as you can see from the some field ground photographs. Now, along with the surface ruptures which are taking place, this could be probably in possibility of fault scarp, which is where we can see the displacement coming right up to the surface. So, this is your fault scarp here. So, this is nothing but the surface manifestation of the displacement taking place along the fault. Now, apart from this, there is another secondary phenomena which is usually been experienced during strong ground shaking, is what we call the liquefaction. Okay. So, liquefaction will take place far away, wherever, like even it can take place within large magnitude earthquake up to like 200 to 350 kilometers away from the epicenter. Okay. So, it is not restricted to the epicentral area only, and this occurs because of the uh, the loss of shear strength of the material, and the increase in pore water pressure of the water saturated sediments near to the surface. Now, as I told that we have a couple of videos which we would like to show you. Okay. And before that, so this is another ground photograph showing the rupture, and you can clearly see the straight rail tracks getting deformed here. Okay. So there was a clear cut offset of the streams. This again we can categorize the fault runs somewhere here. Okay. So this tracks have been dragged like this, and this is again, this has been dragged like that. Okay. So this is very clearly which shows the combination of this right lateral movement. Okay. So this becomes like this, moves like that. Okay. So it is a right lateral strike slip movement over here. Now this is a video which we will play later, but I would just like to explain that if you carefully see this part here, a very sharp boundary or a cliff, okay, or we can say even the escarpment, this is what we call the fault scarps. Okay. So this side is uplifted below, before the event this side was as same as this one. Okay. But this was uplifted and moved laterally. So it has an oblique slip along this. So this is up and this is down here. So this video was when like and the fault displacement along the fault has been explained by Professor Kelvin Berryman. He is one of the very famous paleoseismologists from this area. Okay. So this is along the Pap T Fault, and another video.
We're standing here in the Pap T Fault, a few kilometres south of the Clarence River Bridge on the Kaikoura coast. Looking here at actually the fault plane, the plane of movement along the fault itself, where this side here has moved up by about 1.5 metres, and we can see the gravels here and the gravels on that side. But what's really interesting is that we can see lines of movement here on this fault plane which are moving down a little bit in this fashion. And that means we can see, it looks impressive that we're standing here 1.5 metres high, but in fact most of the movement has been along a plane something like this. So this side here has moved forwards by many metres. These fault scarps form very, very quickly, and we know from earthquake physics that probably this fault scarp ruptured across here at a speed of about 3 kilometres a second. So this has uplifted a very large area of new reef here, and the locals here describe not the earthquake noise but the noise of water running off the top of this uplifted platform here. They said that the noise was just horrendous, and on this on the downthrown side of the fault it's actually still even come up by about 1.5 metres. On the other side there's as much as 6 metres of uplift.
Which is along the Ringu fault. Okay. And this shows the pattern of rupture along the Ringu fault taken by drone. Okay. So you watch this and then you will understand that how rupture took place during Kaikoura earthquake. Now, coming to the other part, if we consider the in totality the geological hazards. So, one is your earthquakes, and so earthquakes not only result into great seismic shakings and rupture the surface, but it damages the buildings and the lifeline structures. Okay. So, this is the famous photograph of 1995 Kobe earthquake, okay, of magnitude around 7.6 or 7.5, and then another one is the tsunami, and then we have the slow failures, cyclones and storms. Okay, and so these are the few geological hazards which have been listed here, which definitely affects the human settlements and the property. Okay. Then of course the floods also. Now this is an example from India, where usually we have seen that from the Indo-Gangetic plains, this is from Bihar, every year we face floods in this region. Okay. So general background, if we take in terms of the natural hazards from the Asia and Pacific region. Okay. So we have usually seen that many developing countries in Asia and Pacific region. So Asia we are talking here, and the Pacific region is over here actually. So most of the countries from these two areas are situated in world's hazard belt and are subjected to floods, cyclones, earthquakes, windstorms, tidal waves or tsunamis and landslides. Okay. Because we have oceans here, so this will result into the formation of cyclones, and the coastal areas will be affected, as well as we are having very prominent subduction zones. Okay, over here. Okay. So that will result into the generation of mega earthquakes, as well as we will face the tsunamis from this region. So likewise, from this area we had 2004 earthquake, and from this area we had 2011. Okay. So this is an Pacific side we are having. So this whole area got affected by the 2011 Tohoku earthquake and tsunami, and this area was affected. Not only this, but other areas also over here, but this was been affected by 2004 Sumatra Andaman tsunami and earthquake. The major natural disaster that occurs periodically in this region are largely due to climate or seismic factors. Okay. So if you take here the recent one, from seismic factor we had 2004 Sumatra Andaman earthquake, and from climatic factors if we take, we had in cyclone recent, that is Varda. And if you go back into in few years back, we had Hudhud, we had Phylline. Okay. So there were many cyclonic effects which were experienced along this coast. Okay. Then further, if we talk about the vulnerability, why these areas are more vulnerable, and vulnerability to disaster has increased in couple of decades. Okay. And this is basically because of more and more people are moving towards the urban centers, and environmental degradation is there, as well as the lack of planning and preparedness. So if you do not understand properly the hazard, it will be difficult for you to prepare yourself to minimize the risk and minimize the hazard part. Okay. So vulnerability to natural hazards has increased in the coastal zones also. So this is one of the example which has been given, that if you keep on disturbing the mangroves and the coral reefs, okay, which usually provides the natural protections from the marine flooding and events, tsunami events, you may be affected more as compared to what you will be affected if they are this mangroves and coral reefs exist. Okay. And this was been experienced in 2004, where we interviewed many survivors, where they had the less affected tsunami in the locations where they had thick mangroves and coral reefs. Okay. So, in total if we disturb the environment, we may face more problems, and if you are disturbing the environment, the natural processes are becoming more hazardous to us. I will continue in the next lecture from here, and thank you so much. We will see you next and during the next lecture.